minute, the call on videos don't seem to have many views, Triv. I feel like we should maximise this.
Yeah, you're right. We should try and pull in new viewers by doing something different.
Something different.
Something really different.
So different.
Something differentiation. So that's what we're on to now.
Yes, it ties directly in with the rate of change, chapter 8, except it's the step after that.
Yeah, so it expand a little bit on what we had.
So I'm going to pose a question to you.
Alright.
You ready? I'm going to draw up a little... Oh, I'll draw a cubic, I think.
Alright.
Just like that. Just something like that. And
That's cubic.
I want you to find the point when x equals 2. I want you to find the gradient of that for me, please.
Alright, well, we're on an equation.
I'll give you that. Not dy by dx. Y equals...
That's what I'm going to do.
That is what you're going to do. I'm going to say it's 2x cubed minus 24x plus 6. That's your equation. You should...
Alright, so remember what we did before? We have, when we do dy by dx, we have our ax with ab, then b minus 1, so I'll do that over here. I'm going to do the different notation, f of dash.
Very nice, very nice. Now I should mention, just for Trev's benefit in case he's forgotten, if the gradient is positive, it's increasing, and if it's negative, it's decreasing. So let's see what happens here.
That's 24, and then the 6 will disappear. So you wanted to find it at 2.
At 2.
Alright, so I'll put 2 in. So I've got 6 times 2 squared, which is 4, minus 24. So that's, okay, that's 24 minus 24, and that's when that equals 0. What does that mean? Positive.
Can't. There is an explanation. When it's
Broken
0,
maths.
it's not increasing or decreasing. It's called a stationary value or a turning point. So in this example, this would be 1, and you've done it when x equals 2, so it would be that one is the one you've just found.
So when it's a turning point.
Yes.
As gradient 0, how do you know which way it's turning?
Well, that's easy, Trev. You just do, you find a point there and a point there, and then you do the gradient there and the gradient there.
No.
Find out that that one's negative.
I think that's rubbish. I
positive.
think that's rubbish. I'm sorry, Wayne. That's a bit harsh. I'll get you some tea to make up for it, but I think I remember a better way to do it. How about we differentiate again?
You mean differentiate this differentiated bit in a differentiator amount?
I do mean that.
Alright.
So if we do that again, it will give us something called the second differential.
It makes sense, second derivative.
Yeah.
And do the d squared y over dx.
It's written a bit
squared.
differently.
But you do the same thing. You times the 6 by 2 now. You get 12. Reduce the power by 1. It's x. The 24 will now disappear. And that's that.
And then we put our 2 in.
When you put your 2 in, it tells you something very special. It doesn't tell you the gradient anymore.
No. It will give you a number, but that number isn't the gradient.
No, and sometimes it's positive and sometimes it's negative, and it tells you if it's what's called a maximum or a minimum.
So we have our 2 points here. If we were to do it here, it would be a maximum, which means it's about to start decreasing.
And it's the opposite to what you'd think, because this is a positive number, yet it's a minimum.
Yeah. But it's positive, it's about to increase, but it is a minimum because it's the bottom point, so it can't get any lower than this.
And that's what it means. You do your second differential, you get a number. If it's positive, it's minimum. If it's negative, it's maximum.
And that's quite useful. Say if we were a business and we didn't know the rest of that bit, we could work out what might happen soon by doing this.
Yes, because if you're a business, you don't know if it's going to keep going down, it might do that sort of thing, or it might just shoot back up. You need to know.
You do need to know. So, with that in mind, I think we should do a test question, because this chapter is quite little, but when you put the 2 videos together...
Yeah, they add up because they're the same thing, differentiation. This is the second derivative, so let's do a test yourself.
Alright, something a bit different. There it is. Wayne, it's so dark. What's happened? Like, I can't see the maths.
Just remember, Triv, maths can be found in even the darkest places, if one only remembers to turn on the light.
Well, there you go.
Yes, it's a bit darker than from when we last had it. It's almost like we got hungry.
And I got some food.
That wouldn't happen.
No, because we're very
and we got straight on to Test Yourself, page 135, question 3 from this book.
Absolutely. I'm going to read it and Wayne's going to do it. And that was some nice chicken. Right. So, the size of a population, P, of birds on an island is modelled by... Ready for this one?
I'm ready.
P equals 59
59
plus 117t
plus 117t
plus 57t squared
plus 57t squared
minus t cubed.
minus t cubed.
Whew. Where t is the time in years after 1970. Part A asks, find dp over tt. Don't panic. Y is replaced with p and x has been replaced with t, so that is just the same as differentiating.
Yes. So 59, that will just disappear. 117t to the 1 just becomes 117.
It is.
57 times 2 is 114t. And then minus 3t squared.
There you are, and that's all part A.
Yep, I think I'll do B and you can, well, I'll read B and you can do it.
Oh. There you are.
And it's a B part 1 and part 2.
Oh, brilliant, there we go. Okay.
Now it says find the positive value of t for which p has a stationary value.
So remember before, a stationary point is when the gradient equals 0. So if we make this equal to 0.
117 plus 114t minus 3t squared equals 0 is a lovely little quadratic there.
It is, apart from it's a horrible quadratic in nearly every way.
Yes.
Start with minus coefficient of x, that's nasty, so I'm going to get rid of that.
So you can take it all to your side, or times by minus is the same thing, it depends on your view. So you get your positive coefficient of, in this case, t squared, but it's just an x squared. Equals 0. Sorry, I'm just used to it being t, then the...
Yeah, I read it wrong around.
It's okay. Then it's also horrible because it's got 117 and 114, but...
We can divide by 3, I hope.
So that's just t squared, I can
Yeah,
do that.
yeah, we can do that one.
I'll leave the rest to you, yeah?
Alright, so 117. Okay, there's only one problem with using a slightly older book.
Back then, you're allowed a calculator, whereas now, of course, you're not.
So this is difficult.
117 to 90, 27, 39. It's 39.
Right, with you.
Instead of 114 being just 3 less is going to be minus 38t.
Oh, I like it. Now this can be factorised. Yes, that's what I was looking for.
Two numbers that times together to equal that and add together to equal that, remembering Trip's done it the opposite way to what you'd normally see in a textbook.
Yeah, that's me. I'm going to swap them round.
Just to avoid confusion.
Yeah, because I was reading it from that side.
Yeah. So it's minus 38t minus 39. So now it's the way around it is in the book. Two numbers that times together to equal this and add to equal that.
And that's okay, so it's minus 39.
And plus 1. That was a nice easy one. It was the simplest possible one.
Good find, so then we know that it's opposite of that, so it's 39.
Equals 39
And
minus 1.
But I think it asked for the positive one.
It did specifically say find the positive value,
So
we'll circle that.
So t equals 39. Okay, that's part 1.
There's a part 2, however.
Oh, alright, so I'll do that down here.
Okay. Determine whether this stationary value is a maximum or a minimum.
Right, so now we need to find a second differential, but of this one.
This top one.
This
here.
top one, well, that's the same thing.
Oh, yes, it was this.
So we're going to do that.
And you know how to do that, it's just differentiating. that
Again.
Again.
So it would be d squared p over dt squared. So 117 disappears.
114
becomes just 114.
minus 6t.
Okay. And now we're putting in 39.
Yes, because this 39, it says in, well, part 1, if you read it, is the stationary value. So you put that stationary value into this to find out if it's increasing or decreasing.
So now we need to work out what 6 times 39 is, which is...
It doesn't matter exactly, because 114 minus 6 times 39, I know 6 times 39 is going to be bigger than 114.
True, so we know that's going to be negative. And if it's negative, it must be
a maximum. The opposite to what you might think. In the exam, it would would be easier numbers than this, most likely,
Yeah,
because you
and-
don't have a
And
calculator.
then work it out, and then you say it's less than 0. So therefore maximum, you could do a...
This implies
This
side,
implies side.
which looks like this.
Very nice. Oh, sorry, I should have done it then, really.
Equals with an arrow. That means this implies.
It does. And that's pretty handy.
There's a part C, which Triv can read to me, 'cause it's only fair.
It's like reading a bedtime story, except maths. So, C part 1, again 2-parter.
Oh, I think you planned this.
I think I might have done.
Do
State
you want to
the...
swap places?
Yeah, that's a good plan. State the year when the model predicts that the population will reach its maximum value. So, now I'm thinking of when this will be greater than 0. Sorry, I was thinking around. Greater than 0.
Yes.
So,
So we've got ourselves a little inequality here.
we have...
We've got minus 6t plus 114. I did it different way around to how it's drawn there.
You did.
It's the same thing.
And we need to make it greater than 0.
Yes.
Yes.
So,
So treat it as an equals sign to start with.
114 negative times by a minus. You've got 6t less than 114. Then t equals, oh, it's less than, what's 114 divided by 6? 39. 38.
38.
38. So then we add that onto this 1970, because it's said in the question that it is t equals years after 1970.
So it'd be 2008, except after, so 2009.
Yes, because at 2008 it's getting to 0. So
Yeah, and we got 2008 by adding 38 to 1970.
yes, so 2009 will be the first year that it's greater than or less than. I've forgotten already what the question was.
Will reach its maximum value.
Reaches maximum. That's the year it will have reached it. This will be it just about reaching it.
Just about reaching it. So then it says part 2, determine what the model predicts will happen in the year 2029.
2029. Or that's 59 years after this 1970.
It is. And if you put it into our original equation, it was the population, so that will tell us what it thinks.
Yes, so 59 is now your t.
Yep, so it becomes 59 plus 117 times 59 time plus 57 times 59 squared. Take away 57 cubed, which is a lot. I think we're going to need a calculator. This is going to be silly otherwise. Well, oh, you got one.
There you go.
Oh, thank you.
So yes, we found the 59 was, because it's in 2029 and this starts at 1970, that's 59 years into since this whole equation is necessary. You put in the 59, it will give you the population, and so forth you can tell what's happening to the population. And the population is?
0. They're all dead.
Yeah, this particular species of bird is as dead as a dodo. Maybe it was the dodo.
Maybe it was. Well,
No, I doubt it. Dodos are extinct now and it's not 2029. However, my time machine is working. Things are a bit higgledy-piggledy at the moment.
Yeah, anyway, this is differentiation, and I don't think we'll do a summary.
No, because this was quite a short video, despite the chicken in the middle.
Despite the chicken in the middle. It was short for you.
You're short for you, or should be.
Should be. If you get them both together, it sort of links on, but as always, you can ask us questions from sending them to our Facebook page.
Yep. Or you can comment it on our YouTube.
You can.
We should get a little beepy beepy saying that someone's commented, and we'll look at it and go, we'll go, oh, we'll help you.
Yeah, we'll send you a video. If
In
it
much
needs
more detail than this, we explain every little detail.
and why we do each step. So, yeah. Ta-da. And now I think we're on to the last few bits of core 1.